I'm Anil Kumar. In this video, we'll further explore direct and partial variation. Now, we'll look into identify initial value and constant of variation from the table. We'll also look into whether the data represents direct or partial variation, right? And once we have found initial value and constant of variation, we'll also write an equation to represent data, right? So that is what we are going to do in this video. So I added all these up so that we have a good example to understand all the concepts. So let me take two examples here. One, I will take a simple example. Let us say we have x is independent variable, y is dependent variable, and at 0 the value is 0. At 1, let us say it is 4. At 2, it is 8. At 3, it is 12, and so on. Let us say that is the data for us. Now, can you tell me whether this data represents direct or partial variation? Since we have 0, 0, since we have 0, 0, it is direct variation, right? So first question to answer here is whether it is direct or partial. We find that the coordinate 0, 0 is in the table, and that means it is direct variation, right? So that is direct variation. Now the second question is, what is the initial value? Now, initial value is always referred to the value at x equals to 0. So the value is 0. The y value, right? So we say initial value is 0. Right? So that is the initial value, right? So let me highlight this. So this is the initial value, 0, 0. What is the constant of variation? That is to say, as I move up by 1, by how many times does the y value increase, right? So what we find here, that the relation between the two is times 4. Do you see? 2 times 4 is 8, right? So what is really happening here is, as we move 1 unit for x, you go up by 4 in y. So this difference of these values, difference 4 minus 0 is 4, 8 minus 4 is also 4. Here it is 1. Do you see that? Here the difference is 1. So for every unit change in x, y changes by 4, and therefore constant of variation is 4, correct? So that is the way we can find constant of variation. So we normally represent initial value with the letter B, and we represent constant variation by letter M. So let me write constant variation. In equation we'll write it in letter M. In this particular case it is 4, right? So that is equals to 4. Once we know all this, we can write down the equation also. So the fourth thing which we can get from this data is the equation itself. Now equation really means how is y related with x. So here this equation is y is equals to 4 times x, correct? Now equation helps us to find any other value. If I write 10 here, then y should be how much? 4 times 10, that is 40, correct? So I hope with this you understand how from the data we can figure out whether it represents direct variation or partial variation. We can read the initial values. We can also calculate the constant of variation. Now general formula for constant of variation will be, let me write down here, m equals to y2 minus y1 over x2 minus x1. Sometimes we say change in y divided by change in x. That is constant of variation, right? Now keeping all these things in mind, I would like you to answer same questions for next set of data. So let me just sketch the table here, write down the data here. So in this case, let us say x and y are our variables, and Let me write down this time values as 0, 2, 4, 6. So I'm going up by 2. Remember that, okay? On this side, let me start with 10 instead of 0. And let me go up by, let us say 6 this time. So 10 plus 6, 16, plus 6, 22, plus 6, 28, and so on. Now the question is, this data, what does it represent? Does it represent direct or partial variation? So, well, since at 0 we have 10, so we have 0, 10, that means it is partial variation, correct? Partial variation. So we got the first question. The second one is, what is the initial value? So the initial value, let me write B as initial value, is the value at 0, right? So at x equals to 0, it is 10. So initial value is 10 for us. So that is the initial value. Now, let us find what is constant of variation. Constant of variation, normally we write m for it, is change in y. Change in y is 16 minus 10. 16 minus 10 divided by change in x, which is 2 minus 0, right? 16 minus 10 is 6, and that is 2. So we get 3. So m is 3. Once we know all that, what is the equation? So the equation should be y equals to mx plus p. So y equals to mx plus p. Constant of variation is 3. So we can write this as 3x. So we get y equals 3x. And b, the initial value is 10. So we get 10. Do you understand? So that is how we can get the equation. Equation helps us to find any other value. For example, if I write 10 here, then what is the value of y? 10 times 3 is 30, plus 10 should be 40. So we'll get 40, correct? So that is how you can actually calculate other values from the given equation. But I hope with this you understand all the concepts required for direct and partial variation. This should help you to answer any question from your book. Thank you and all the best.